circuit looks after soldering. And these are the LEDs and respective resistors of the LEDs, and these are the female connectors for the Arduino. And this is a main hall sensor through which the sensor input is going to the Arduino, and it is how it looks behind. And these are some of the wires, and you can see a small lithium polymer battery over here, which is connected to a female header so that it can be inserted over here, and this is the main on switch. So what you need to do is now just insert the Arduino over here, and just connect this here, and that's it. And just if you switch it on, yeah, the circuit is on now. Now I will show you the working. Hence you all know that the Hall sensor is a sensor which detects the magnetic field. This is our main sensor where you can give the input to the Arduino. You can see over here, when I bring the magnet close to the sensor, the signal goes to the Arduino and the LEDs get on. The remaining part I will explain you after adding this circuit to the main frame where this whole circuit is going to rotate. I will show you how to do that. This is the main wooden frame where this circuit is going to sit on this, and you can build this by your own. Just take a piece of a plywood and another two pieces and just clip them over here in this fashion, and you can get a stand like this and place a magnet, neodymium magnet, or you can use any kind of magnet. I've used this glue because to increase the height a bit. And this is the DC motor, and just solder the two wires behind this, and just you need to add this plastic gear backside of this circuit so that you can insert this to the motor. Just take a plastic gear and keep it over here and add some hot glue, and then use Fevikwik so that the hot glue doesn't come off from the board and it stays strong. And now just put it on the motor. Yeah, it's ready. It looks something like this, and the DC motor will be rotating it, and I will explain you now how it works. The thing what happens here is, whenever this Hall sensor comes over this magnet, the lights get on. So basically how the program works is, when this Hall sensor comes on this magnet, for like the speed of the motor is such that it comes on this magnet for every 1 second. Like it rotates and comes on that magnet exactly after 1 second. So the how the program is, once it comes after 1 second here, the 1 second in the program gets incremented. So after the 60 seconds there is a 1 minute, and then after this the 60 seconds occur and the minute happens. In same way, the 60 minutes, when it gets completed, the R hand of the clock gets to the next position. So how this is how the clock works. Here I am showing it with the hand, but when you connect this to the motor does the job and you will get the output. So now here I connected these wires of my motors to the power supply, and I switched on the circuit, and the power supply is like set to around 4.3 volts, and let's switch on the circuit. You can see here the some part of the clock is not visible. This is because the motor is not rotating with the right speed. So let's increase the speed a bit. Here you can see if I increase the speed too much, then it starts overlapping with the previous bits. So just keep it right. And it's almost set now, and you can see the seconds hand of the clock clicking at every second at the right time, and the voltage is around 5 volts exactly. So that's all for the working part. I hope you liked it. You can see when I turn it off, slowly the clock stops because the motor speed goes on decreasing, and as I told previously that it needs to rotate at the right speed to get the right time. Hello guys, I hope so you liked the video, and hence this is my first YouTube video, and I am not so well versed with the editing part and not so well how to shoot the video and all. So please do tell me if there are any mistakes. Please do comment below, and yeah, please do like, share and subscribe, and please tell me which videos you want to see next. You can comment down. See you soon with the new video guys. Bye.